Hello, AP Stats. This is Mr. Kim here, and in this video, you will be able to see the walkthroughs of all the questions for Chapter 6 review. We have two review packets, and this will be the part one of the video. So starting with number one, that's the very first thing I have taught you in the beginning of the year. Which of the following data set is not continuous, it says. So continuous versus discrete, we know that this variable here, continuous versus discrete, means that continuous can be decimals. Any numbers in between the integers are allowed. And if we're talking about not continuous, that means that we are actually looking for discrete, which means simply that all of the numbers that is within the random variables has to be classified as integers. So one of the following choices will have all the values as integers, and the only one that gives you an integer value is C. The number of goals scored by a hockey team, it's 1, 2, 3, 4, 5. Gallons, time, distance, and hours, all of these can be decimal values. Therefore, for number one, it's going to be C. Number two, Mrs. Burns teaches two calculus classes, and this is a classic question where you're asked to combine two variables. So they have standard deviation, they have the mean. We want to find out the new standard deviations by combining these two classes. So we're going to focus on these two numbers, 6 and 9. Now, the formula for combined standard deviation is square root of the first variable's standard deviation squared, or we call it the variance. And so the variance of the second square, well, the standard deviation squared. And when you add them and square root it, that gives you the combined standard deviation of the new variable. So we do 6 squared plus 9 squared, and we square root that. And then when you type into your calculator the square root of, I believe, 36 plus 81, yes? So that should be 117. And that should be B for this question. Number three, two random variables, x and y, are independent. So we want to do this, the new variable that's defined as 2x plus y. If I want to find out the mean and the standard deviations of that, first of all, the mean is very simple. I just can think of it as just plugging these numbers in. So 2 times 6 plus 8 gives you 20. So I'm going to eliminate all the ones that doesn't say 20 for that. So we are looking at C, D, or E. For standard deviations, 0.5, by doubling it, yes, that also gets doubled. And the standard deviation for the new x variable will be considered to be 1. And from the previous question, we also know that the combined standard deviation, the formula follows the sum of the variances square rooted. So the new standard deviation for x is 1, not 0.5, because I have to double it, plus 0.6 squared, because that's the standard deviation of the y and doesn't change, and you have to simply square root that. All right, so on the calculator, I can just go to square root of 1 plus 0.36. That's same as 0.6 squared. And so it seems like my standard deviation is 1.16. So it's going to be E for this one. Okay, so for number 4, what is the probability that a randomly selected household has at least 2 cars? At least 2 cars means the probability if x is greater than or equal to 2. So we're really looking at all of these 4 numbers. Combining all of this should give you D for this. Number 5, using the probability distribution in number 4, what is the expected value? The expected value is the sum of all the values with its respective probabilities, and we have 6 of those entries. So rather than typing those up manually into the calculator, I'm going to just use my list. Whichever way you feel more comfortable, I think you should pick. So 0.24, oh, I should delete that, move it over. 0.24, 0.37, 0.2, 0.11, 0.05, and 0.03. And when you do stat calc 1var stats, make sure your frequency list is list 2. And the standard deviation is 1.26 and the mean is 1.45. So the expected value, always understand it as the mean. Sorry, I Just erase that page over. The first number you see is always the mean x bar, so that should be the answer. And when they ask you for the expected value, always make sure you understand that it's the mean. All right, number 6, a dealer in Las Vegas selects 10 cards from a standard deck of 52. Let Y be the number of diamonds in the 10 cards selected. So the last time I checked, the number of suits in a standard deck of cards is 4. So picking a diamond should be 1 out of 4. Which of the following best describes the setting? Now the problem here is that if the card is looked at and not turned back into the deck or not returned, that means the independence of the bins is not met. Remember, independence is one of the requirements for it to be binomials. So when you look at the wordings here, Y has a binomial distribution. Well, it's missing something because it doesn't say whether the card is returned back into the deck or not. Y has a binomial distribution, n is equal to 10, probability of success, provided that the deck is shuffled well. Well, even if you shuffle it well, because we're picking 10 cards, and the chances will change if you don't put the card back. C is the correct answer because we have the word replaced. We want to replace it back into the deck so that each of the probability is not tampered with. So the answer is C. Number 7, in the town of Lakeville, we have a table again. The standard deviation looks like it's back to our calculators again. So I'm going to use that, and then, I'm going to just clear this list because I don't need this anymore. Oh, I should have probably saved that. Same exact thing. And then it's 0.1, 0.1, 0.25, 0.3, 0.2, and 0.05. All right, so one var stats, same thing. And it seems to me the standard deviation is 1.32. Standard deviation is the sigma. Make sure you know what you're looking for. All right. Number 8, a random probability y, random variable y has the probability distribution as such. Remember, to make this valid, all the probability of y, the sum of it, has to equal 1. I know this is not the correct notation, but adding all these numbers up has to be 100%. And this gives me 10%, which means this should give me 90% as the rest of them. And so 6c equals 0.9. because 4c plus 2c gives you 6c. Divide both sides by 6. And I believe the c value is 0.9 over 6, which should technically give you about 15%, I believe, if I'm not mistaken. But just to be sure, 0.9 over 6. Yep, it should be 15%. All right, so the next question, the variance of the sum of two random variable x and y. So for this, we know that the variance is the standard deviation squared for x and the standard deviation of y squared, and the sum of that should look like this. So it's not A, not C. The variance of the sum of two random variables should be D. B is the same thing, but it has to be independent as one of the requirements. So the answer here is D. Number 10, it is known that about 90% of the widgets made by Buckley Industries meet specifications. Every hour, a sample of 18 widgets. Okay, so we're given N, we're given P, and they're asking you to define the mean and the standard deviation of the distribution here. So because we know that this is a binomial distribution, because we have either widgets meets the specifications or not, and the number of trials is fixed, and each widgets are independent from one another, as we can see. And so the mean of the binomial distribution should be n times p. The standard deviation should be n times p times 1 minus p, and then square rooting that. 18 times 0.9 should be fairly simple. It should be 16.2. So I'm eliminating a and b. Plug into the formula for standard deviation. I think you should be all set. So the n times p should be 18 times 0.9. And I'm going to multiply that by 0.1. Square rooting the answer should give you 1.27. And so the answer here should be should be D, excuse me. That should be the standard deviation. Number 11, the expected profit when playing a raffle. So it sells for $10, which means you actually have to pay $10. So that's minus 10. But let's find out the expected value of the revenue. So how much are you expected to earn from this? So it seems like the table has 4 entries with its 4 respective probabilities. So we're going to type in 0, 500, 1000, 2000. So these are the values and its respective probabilities. Okay, so stat calc, one var stats, everything should be the same, and there we go. So it seems like our expected value is $595 as our earnings, which is quite high, but because we're talking about profit and not the revenue, you have to subtract $10 because that's the amount of money that you paid. So the answer here should be B. And if I check with the answer key for number 11, yes, that should be B for this. All right, number 12, let the random variable x represent the amount of money Carl makes tutoring statistics. X is normal. They gave you mean of the standard deviation. The probability is approximately 0.6 that in a randomly selected summer, Carl will make less than about. So we want to do the percentages given, and we want to find out the value. In order for us to do that, we always have to go to our good old friend, second var's inverse norm, because the first thing that they ask you is always the area, and the area is 0.6. We make less than about, so 60%, and we are talking about less than. And so the mean is 240, and that's 60. And the tail should always be on the left, so 60% towards the left means 60% or less. And when you do that, you get a nice number of $255, which means if Carl made about $255 or less, then it's about 60% or 60 percentile in the normal distribution curve. Okay, flying through these. Number 13, find the probability of x is equal to 5. Now, there's a small typo here. All of this should be shifted a little bit to the left. So I'm gonna redraw this table. So it's the values are 1, 2, 3, 4, 5. That's 0.1, 0.2, 0.3, 0.3. And I think you guys can guess what this question mark should be. It should be 0.1. Because remember what I told you, all of these numbers has to add to give you 100%. So the only number that adds up to 100% given all of these 4, which adds up to 0.9, should be 0.1. So that is the answer for part A, coincidentally. Find the probability that the pain score is less than 3. That's adding up these two, which is 0.3. Find the mean of the distribution. Again, I have no choice but to just use this over and over again until I get very sick of it. Clearing the 2 lists here, we have 5 entries. So we have 1, 2, 3, 4, 5. And then the respective probabilities. Stat calc, 1 var stat. And then when you calculate, my mean is 3.1 and my standard deviation is 1.13578. So I'm just going to write those down. And here, I'm going to write down that that's the mean or the expected value. The variance doesn't tell you, but since I know my standard deviation is 1.13578, I can just square this value, and then I can find the variance. So what I can do is I can go here, second mode, and then I'm going to type in 1.13578, and you square that value, and then my variance should therefore become 1.28996. Or I'm sorry, 9996. Like I said on the day of the test, it really doesn't matter as to how much you decide to round up. About 10,000, 1,000th place or 10,000th place is good. For me, I just wrote down as much as possible here, but it doesn't really make a big difference. Don't round it up to 1.3 though. That's one thing I will not allow. All right, so part F, suppose the pain scores for 2 randomly selected patients are recorded. So we are talking about having this one set and we're having another one, and we're combining them because it's the sum of those 2 scores. Find the mean of Y. Well, remember, the mean of Y is the same as those 2 means combined, which is 3.1 plus 3.1, so it's 6.2. Because the mean is given to us as 3.1 and we just do it twice. Find the standard deviation of Y. Now this is where you take the standard deviation, or you can take the variance that's given to us, which is 1.289996 plus 1.289996, and you square root that. Remember, you can always sum up the 2 variances, and then when you want to find out the standard deviation, just have to square root it, to add the finishing touch. So here, I'm just gonna double that because that's same thing as saying adding it twice. And then, or adding it additionally one more time to itself. Square root answer 1.60623. That should be the standard deviation of the combined variable here. Number 14, if a player rolls 2 dice and gets a sum of 2 or 12. Now, anytime when they talk about dice and adding it up, I think it's best if we just write out all the possibilities out there. Because it's really hard to envision this the first time around, and this table really helps out with a lot of dice questions. So you're just going to add these up. So 2, 3, 4, 5, 6, 7, 3, 4, 5, 6, 7, 8. And you can probably see the pattern, like diagonally, they contain like all the same numbers. So I can just kind of show you the trick. Oh, that should be 7. 8, 8, 8, 8, 9, 9, 9, 9. Good. All right, so if a player rolls 2 dice and gets a sum of 2 or 12, notice how it happens just twice. Like, it happens up here and happens down there. So that's 2 out of a grand total of 36 total events. If you count up all the possible events here in red, that's total of 36 different possible outcomes. And he wins $20. So remember, it's always the probability times the value, which is $20. If the person gets 7, that's 1, 2, 3, 4, 5, 6. That's 6 out of 36 times a chance that the person can win $5. The cost to play the game is 3. So this, summing them up, should give you what we like to call the profit, or not the profit, but how much money you're going to get from this game. But you have to pay the $3, which means you simply have to subtract the 3 at the end. So rely on your calculator one more time. We're just going to simply type this in. So 2 out of 36 times 20. And we're going to add 6 out of 36. Well, times 5 out of 36. Which gives me 1.9444. Now, if I were to subtract 3 from that, that gives me negatives 1.055 repeated, which means per game, you're expected to lose about $1.05. So if I were you, I wouldn't play this game. That will be the sort of the conclusion you can make from this. Okay, so that's the expected value of this game. Let's move on to number 15. So for 15, here's the probability distribution function for a continuous random variable. Now, what we have is that we have this graph where everything underneath the curve, you can think of it as a histogram, or, all this area per bar is the chance of that event happening. So probability of x is equal to 1, for example, that is a grand total of 0.3. If I were to draw myself a table like this, so 1, 2, 3, 4, 5 are all of my possible outcomes. We know that's 0.3. Seems like 2 is at the same spot, so 0.3 one more time. Now for 3, it's a little weird because you have this diagonal shape, but that's the same thing as having like a triangle. And we know the triangle is always 1/2 base times height for the area. Or you can think of it as taking this rectangle and cutting it in half. That is 0.1, but it's half of the 0.2 that's above it. So that's additional 0.1. So that is 0.2 for a numerical value of 3. This triangle right here, that only amounts to 0.1, because this entire rectangle, the 2 boxes, should be 0.2, but think of it as cutting in half. I hope that gives you enough idea for 3. 4 is easy, and 5 is easy. And lo and behold, they all add up to 1. So we're all good. Determine the following probabilities. So 0 to 3, I'm looking at, I guess actually there is no event for 0, but we're going up to 3. So we are adding up these, so that should be 0.8 for 15. Yes. And for part C, we have 2 and 3. So between 2 and 3, it's these two. So that should be 0.5, I believe, in grand total. Find the area under the curve between 2 to 3, it says. What they said was that it was gonna actually 0.2, but for the answer key here. Find the area under the curve from 2 to 3. Probability distribution here. Oh, I'm sorry. So I guess they had another typo here as well. That 0 should also exist. So each of these bars actually represents between 0 to 1, and then between 1 to 2, and between 2 to 3. So you're not really looking at these numbers. Rather, you're looking at the numbers in between. So this entire first bar, that first bar represents from 0 to 1. The second bar represents from 1 to 2. The third bar represents from 2 to 3. So that makes sense. So 2 to 3 right here, that's the probability of what they're talking about. So that should be 0.2 because it's this. It's just this only. Yes, the graph is a bit unclear. I thought that each bar is represented at those specific locations, but given how it's stated with the 0 being a little bit an awkward place actually, and I think we're just gonna go with this as our answer in total. Yeah, because we're supposed to have x value as 0, and that's probably the reason why there's a little bit of a confusing sense here. Number 16, a manufacturer produces a large number of toasters. From past experience, the manufacturer knows that approximately 2% are defective. In a quality control procedure, we randomly select 20. Okay, I think it's pretty obvious what this is. Is binomial distribution appropriate? Yes. Why? B, it's either you have defective or not defective. I, independent. From each of the toasters, they're different, so they will have each different chances of being defective, and one's toaster doesn't impact the chance of the other. N is 20 and S is 0.02. So all those conditions should be checked out. When they ask you for something like this during FRQ, please just use bins. You should be fine. Incomplete sentences. Part B, determine the probability that exactly one of the toasters is defective. So we're going to do binomial PDF, okay, of all the numbers that's given to us. I think the first thing they ask you is the number of trials here. So binomial PDF, sorry. The trial should be, I think there was 20 trials, right? So 20 trials with 0.02 being defective, even though defective is a bad thing, but that we're going to consider that as our chance of success because that's the thing we're looking for. And X value, we want exactly one of these toasters to be defective. So the chance of that happening is 0.2724. So that's 20, 0.02, 1. Like I said before, if you use the formula that looks like this, you will still get the same thing. N is 10, K is 1, and P as 0.02. Define the random variable X. That's what is this? Define the random variable X, number of defective toasters, because that's what we want to find out. That's the thing that we're interested in. Then find the mean of the standard deviation for X. So the mean is always N times P for binomial. Standard deviation is square root of N times P times 1 minus P. So it's 0.02 times 20, which should give you 0.4. For this, we have square root of 0.4 times 0.98. I have to constantly use my calculator, but this time I'm going to just use this. So I don't have to keep on switching back and forth. I don't really need to show you the screen for that, I'm pretty sure. So 0.392 should be your mean and the standard deviation. And verifying our answers here for 16. Okay, and part C, we have 0.4, and then we have 0.626, right? So we forgot to square root that. So that square rooted should give you 0.626. There we go. All right, so find the probability that at most 2 of the toasters are defective. At most 2 means, okay, binomial CDF, because we want 2 or less. At most 2 means that. So include enough details so that it can be understood how you arrived at your answer. So simply go to your binomial CDF. Number of trials is fixed as 20. Probability of 0.02. At most 2 means 2. All right, so the chance of that happening is 99%. Okay, so binomial CDF with number of trials, chance of defectiveness, as well as the number that you're going up to. And the answer should be 99.29%. Okay, so I'm going to stop here for part one. There are a lot of FRQ questions here, but we were about halfway there. So hopefully this helped you from 1 to 16, and I'll see you in part 2 of the video.